In this world of networking, where countless devices connect and communicate seamlessly, there's a need for a clear structure that explains how this communication happens. That's where the OSI model comes in, a framework that has become the backbone of understanding network interactions. But what is the OSI model, and why is it so important? In this video, we'll explore its layers, their roles, and why this model remains a cornerstone for both networking students and professionals alike. The OSI model, or Open Systems Interconnection Model, simplifies how devices communicate by dividing the process into 7 layers. Let's quickly break it down and see how each layer contributes to smooth network communication. 1. Physical layer. This is where the actual transmission of raw data occurs via cables, radio waves, or other mediums. 2nd, data link layer. It ensures error-free data transfer between 2 directly connected devices and manages MAC addresses. 3rd, network layer, responsible for routing and delivering data across different networks using IP addresses. 4th, transport layer, ensures reliable data delivery, using protocols like TCP and UDP for error checking and flow control. 5th, session layer, establishes, manages, and terminates communication sessions between devices. 6th, presentation layer, handles data translation, encryption, and compression to ensure compatibility. 7. Application layer, directly interacts with the user, supporting applications like web browsers, emails, and file transfers. Each layer works independently yet cooperatively to ensure smooth and reliable communication. Together, they create a standardized system that simplifies networking across the globe. The OSI model's role goes beyond theory. It standardizes communication, simplifies troubleshooting, guides protocol design, supports network scalability, and ensures interoperability between devices and systems. The OSI model remains essential because it simplifies network communication into clear layers, provides a universal language for networking professionals, and streamlines troubleshooting by isolating issues to specific layers. It's also a foundational tool for students and a guide for designing protocols, making it invaluable in both learning and practicing. And that's a quick overview of the OSI model, simplifying network communication into 7 layers.
HTTP Hypertext Transfer Protocol. HTTP is a protocol used for web browsing and works over a connection-based system called TCP. It allows a browser to send a request to a server, which then responds with data, such as a web page. It operates at the application layer, layer 7, of the OSI model, but does not provide encryption, meaning data sent over HTTP is not secure. HTTP/3 Quick. HTTP/3 is the latest version of HTTP and uses the Chikhi protocol, which runs over UDP instead of TCP. This allows it to send multiple streams of data simultaneously, making it much faster and more reliable in high latency or real-time environments. It operates at the application layer, layer 7, and uses UDP at the transport layer, layer 4. HTTP/3 is ideal for IoT, virtual reality, and other speed-sensitive applications. HTTPS, Hypertext Transfer Protocol Secure. HTTPS is a secure version of HTTP that encrypts communication using TLS, Transport Layer Security. When a client connects to a server, a public-private key exchange is used to create a shared session key, which encrypts all transmitted data. HTTPS ensures privacy and data integrity and is essential for activities like online banking and secure logins. It operates at the application layer, layer 7, with TLS functioning between the application and transport layers. WebSocket is a protocol that starts with an HTTP handshake, but then upgrades to a persistent two-way communication channel. This allows the server and client to exchange data in real time without repeatedly opening new connections. Operating at the application layer, layer 7, WebSocket is commonly used in live chats, online games, and real-time notifications. TCP, Transmission Control Protocol. TCP is a reliable, connection-oriented protocol that ensures data is delivered accurately and in the correct order. It uses a three-way handshake, SYN to SYNA, CK to ACK, to establish connections. TCP is essential for web browsing, email, and file transfers, and it functions at the transport layer, layer 4, of the OSI model. UDP, User Datagram Protocol. UDP is a connectionless protocol that sends data without verifying its delivery. This makes it much faster than TCP, but less reliable. UDP is ideal for real-time applications like video conferencing, online gaming, and streaming, where speed is more important than perfect accuracy. It operates at the transport layer, layer 4. SMTP, Simple Mail Transfer Protocol. SMTP is used for sending emails from a client to a server and between servers. While it doesn't include encryption by default, it can be paired with secure protocols like TLS for added safety. SMTP is a protocol at the application layer, layer 7, and is key to how email systems deliver messages across the internet. FTP, File Transfer Protocol. FTP is designed for transferring files between a client and a server. It uses two separate channels, a control channel for sending commands and a data channel for the actual files. Operating at the application layer, layer 7, FTP is widely used for uploading and downloading files, though secure versions like FTPS and SFTP are preferred for sensitive data.